Okay, what is the difference between mass number and atomic mass? Yes, Delcine.
Mass number more powerful than neutron.
Yep.
Decimal number, and it's not found on the periodic table.
Okay, so mass number is protons plus neutrons.
Yeah.
It is not on the periodic table. It's always a whole number. Because you can't have a fraction of a proton or neutron, right? You can't have 0.3 neutrons. Okay. Was there anything else you wanted to say about that one? Yeah. Can you do the atomic mass? Well, not just yet, because I want to add one more thing. This is different for each isotope. Okay. And what's that word that I just said? Isotope. What is an isotope? What are isotopes? Tell your partner. Isotopes are different versions of an element. I'm going to say element. Different versions of an element. And what makes them different from each other? Tell your partner. What makes them different from each other? I'd like someone other than Delcine to answer me. Not because I don't want to hear from you, but I'd like to hear from somebody else for once. Somebody else. What is different about isotopes? Yes. Different numbers of neutrons. Okay, so they have a different number of neutrons. And if they have a different number of neutrons, what else will be different about them? Their mass number, yes. Okay, so that is what mass number is. It is for a specific isotope. So you have carbon 13, it's got a mass number of 13. You have carbon 12, it's got a mass number of 12. You've got carbon 14, it's got a mass number of 14. All whole numbers, protons plus neutrons. What is atomic mass? Yes.
Atomic mass is the average mass found in the average mass of the isotopes of that element.
It is the average mass of all the isotopes of that element, and it is a proportional average. Okay. Now you guys probably know about taking the average if you have 5 numbers. So let's say I have these 3 numbers, and I wanted to take the average. I would divide by 3. That's how we normally take an average. Shh. But that's not how we take an average to find atomic mass, the average atomic mass. And it's not how I take the average of your grades. I have had people add up their tests and their quizzes and their homework and their labs and divide by 4. And they do not get the same answer as on their progress report. And that's because quizzes are worth 10%. So if you wanted to find your percent, you would say, okay, I have 10% on labs. How do you write 10% as a decimal? 0.1. So I would say I've got 0.1%. And let's say on my quizzes, I got, this is quiz. I can't write Let's say I got 70%. Quizzes are worth 10%. Labs are worth 10%. So once again, 10% is 0.1. And this is labs. And let's say I got, let's say I got 100% on the labs because I'm amazing. And then we're just going to have tests. How much are tests going to be worth? 80%. What's 80% as a decimal? 0.8. And let's say I got 90% on my test. So what I would do is I would take 0.1 times 7, 0.1 times 100, 0.8 times 90, and I would add them up, and that would give me my overall grade. Yeah? And that's how average atomic mass also works. So for example, in this one on our next page, on page 19, you can see that boron 10, what did they say the percent was of boron 10? I can't remember. 20%? Boron 10 is 20%, and boron 11 is 80%. So in order to find the average atomic mass, what we would do is we would say, I'm going to take 0.20 times 10 plus 0.80 times 11. Okay, and if we do that, 0.2 times 10 plus 0.8 times 11, you get 10.8. Does it make sense that this number is closer to 11 than it is to 10? Right? Because we have more of the boron 11. That's why we can't just take the two numbers and divide by 2, because we have more of the heavier one. So it should be closer to 11. Okay? So let's go and try. Let's go back to our other page, which was 3.3a. There we go. And that was on page 55. Gallium has 2 stable isotopes. We have gallium-69, which we could also write as Ga. Where would we write the 69? On the top left. Okay? Gallium-69, and that is at 60.11%. And we have gallium-71, which is at 39.89%. And now it turns out that when we say the mass is 69, the mass isn't exactly 69 because you actually lose a little bit of mass from each proton and each neutron when they, or you gain a little mass or something. It has to do with how they bond together. And it's actually Einstein's E equals mc squared. Yeah, E equals mc squared is turning some of the matter into energy when the nucleus comes together, when all the particles of the nucleus come together. So it's going to lose a bit of mass that will be turned into energy. Okay, so that's why, and you don't really need to explain that, but that's why gallium-69 actually has a mass of 68.926 AMU. It's a little bit less than 69 because when you put all the protons and neutrons into the nucleus together, a little tiny bit of that mass gets turned into energy. We don't need to understand that because this is chemistry, not physics. We just need to be able to read the number in the question and say, okay, that's what it is. Yes? Abundance means how much there is. How abundant is it? If it is very abundant, that means there's lots of it. If it's not very abundant, there's not very much. What is its percent abundance? It is 80% abundant. We have that much of it. It's how much we have. Okay, so abundance means how much we have. So percent abundance is what percent is this one, what percent is that isotope. Okay? And gallium-71 isn't really 71, it's actually a little bit less. It is 70.925 AMU. All right. And what we're now going, this is the percent abundance. Of each of our isotopes. So we just use a very, very straightforward formula. Every time you get one of these, super easy. You take your percent abundance and you turn it into a decimal. Do you guys all know how to do that? So 60.11%, what would that become? It would become 0.6011. So we take the percent and turn it into a decimal. Are you guys familiar with that? That's something we've done in math before. Anyone not done that in math? Everyone's done it. Okay. And then if we have our 39.89%, that's going to become what? 0.3989. And what we do is we take our decimal. I call this the decimal percent. Okay, the decimal percent. We take our decimal percent and we multiply by the mass of the first one. So the decimal percent of A times the mass of A plus the decimal percent of B times the mass of B. And you don't need to show all of this work every time, right? You can just go straight to showing me the numbers, okay? So all of this up until now is just me showing you what you're going to do to set up the problem. So really what you should do is you should say, okay, my decimal percent of A, 0.061, that is gallium-69, which is 68.926. So we're going to take 0.6011 times, what was that number again? 68.926. 68.926. Should I write in the unit for the mass? Yes. Okay. What is the unit for that mass? AMU. What does AMU stand for? Atomic mass units. All right. And so that's A. And then we're going to add to it our other decimal percent. Okay. So we have 0.3989. And that goes with the gallium-71, which is actually this number here. Okay, so that's going to be times 70.925 AMU. And that equals, now you just throw it in your calculator, 0.6011 times 68.926 plus 3989 times 70. Oh, hang on. 0.6011 times 68.926 equals 41.4314. Why am I writing this out rather than just tossing the entire thing into my calculator? Sig figs. Okay? So, this bit here became that. How many sig figs would we have in this answer? We would have 4 sig figs. And that means who is our uncertain digit in 41.43?
1. The ending, the 1 in the end.
Hold on.
Sorry, 4, sorry.
We got 4 sig figs here. We have 5 sig figs here. So we have 4 sig figs here. And that means that our 3 is the uncertain digit. Yeah? Okay. And now we're going to do our other multiplication. 0.3989 times 70.925 equals 28.29198. That's irritating, but that's okay. And how many sig figs should I have there? I should have 4 sig figs, which means that I am now at my second decimal place. And now I add these two together, plus 41.4314 equals, and we get 69.7233, which will round to where should we be rounding to? We're rounding to our second decimal place. Yeah, because our second decimal place is where we have our uncertainty. So there's our second decimal place where they have the uncertainty, 69.72 AMU. Is good? Okay. There's another type of question you could get where it's not just, plug in the numbers and whatever. Rubidium has 2 isotopes, rubidium 85, which is 84.911, and rubidium 87, which is 86.909 AMU. The atomic mass, and remember when we talk about atomic mass, what do we mean? We mean the atomic mass means average atomic mass. Okay, so the average of all the isotopes. And that is 85.47. So we have rubidium 85 and we have rubidium 87. Those are the 2 isotopes. Which of the isotopes is more abundant? What does it mean when I say more abundant? It means we have more of it. Yeah? Okay, it'll have a higher percentage. So chat with your neighbor and decide. This one you don't actually need to do math. You can just think about it.
Yes.
Okay, so which of them, is more abundant? So don't say it out loud. Chat with your neighbor. Try and convince them of your point.
I couldn't remember yesterday, so I got
That's
B,
okay.
so I got B.
Thank you. All good. Okay, is it rubidium 85? Raise your hand if you like rubidium 85. Raise your hand if you like rubidium 87. And be like, I don't know if I don't know yet, which is perfectly fine. I don't know yet is a good answer too. Okay. Is 85, now if we have a number line here, we have 85, we have 86, and we have 87. And this number here would be about here. So 85.47 is closer to 85. Therefore, we must have more of the isotope with the mass of 85. But, yes?
Is this depending on rounding? So 85.47 is.
It won't matter because even if it was 47, even if it was 85.5, it's still closer to 85 than to 87. Okay? Because we're not choosing between 85 and 86. We're choosing between 85 and 87. Yeah? Yeah. If the number were 85.5 and it were an 85 isotope and an 86 isotope, you would have 50-50 of each.
Oh, really?
Yeah. Yeah. So if you're halfway in between, you have 50-50. Doesn't happen very often. In fact, never, I don't think. Okay? Yeah. All right. Do you guys want to try this one on your own?
Yes.
Try it. Okay, magnesium has 3 stable isotopes. Give it a go. And remember, you don't need to write out everything. All you need to do is your percent as a decimal.
You write all those numbers out?
Yep.
We have a 23.9.
Yes. 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 Sorry? Yes, and the flash has disappeared, so you can just go. Okay? I'll figure out something to do instead of the flash. I have a medal that I got from like walking. The operating line. It's not like so much pieces. The other way around. Say no. Yes, you're gonna write the percent of the mass, and the percent times the mass, and then the third one also. Okay. Yeah, absolutely. No, well, there will be like a little extra section. And I need to get that. Just 1 second. Yes. I know.
For this one, I should count the first.
Anybody else need organic? No? Okay. Yes. Is the answer 25? Let's find out. So we would have this one and this one and this one. Yeah.
Oh.
This one thing is. Not like
Okay, now if you don't want to write out AMU every single time, you could instead put this whole thing in big square brackets and put the AMU on the outside. That would also be acceptable. Okay, I'm going to get rid of that though. But you should otherwise write the AMU with all the numbers. We do that and we get, let's see, 0.7899 times 23.985, 18.94. Now, when I do this, if I'm looking at sig figs, I don't need to write down 18.9457515. That's a lot of numbers, yes? I know that this has 4 sig figs. So I should be okay in terms of rounding errors if I keep 5 sig figs in this part of the answer. So this would be 18.94, and then it's 5.7. So I'm going to write 9.46. Okay, because it was not 18.9457. So I'm going to make that a 6. And now I've got an extra digit, but I'm going to remind myself that that is my digit right there. That is my uncertain digit because that is 4 sig figs. And this one, actually, I'm going to write the AMU on the outside because it's irritating to write it every time. Okay, our next one, 0.1 times, oh, I can do this one in my head, 24.986. And our last one is 2.8 6, 1. No, 07, because I want, yeah, 5 sig figs, 07. Did I do that right? What? Oh, yeah. Oh, so sorry. 2.4. 2.4896, and that has 4 sig figs. And this one has 4 sig figs. And I'm going to fix the fact that I don't have units there by putting brackets and AMU. I don't care if you put dots after the AMU or no dots after the AMU, it's fine either way. And then we add them up, 18.946 plus 2.4896 plus 2.8607 equals 24.296. Is that what you got? Did I do something wrong? 0.7899 times 23.985 equals 18.946. Yeah, that's correct. Did you get something different? Oh. Okay. Oh, but watch. But watch. I rounded off here. So if you punch the whole thing into your calculator, you'll actually end up getting exactly the same answer as me, because am I done at this point? Do I just put AMU and say I'm done? I have to round it to how many sig figs? To where?
4 sig figs.
Not to 4 sig figs, but I have uncertainty in the hundreds position, right? And I have uncertainty in the thousandths position. So I'm now going to need to round this to 24.30. Is that what you got?
I got it. 24.34.
You got 24.31. Well, you know what though? Maybe I should have okay, let's try it. 0.7899 times 23.985 plus 0.1 times 24.986 plus 0.1101 times 25.983 equals, it's true. Do you remember how I said there was one calculation in grade 12 where the rounding would be off if you rounded to 1 decimal more than you needed? Well, we have another one here. It should actually be 3-1. I should have kept an extra digit here, here, and here. Okay? Oh. All right. It does happen.
Nightmare come true.
It is. It is a nightmare come true. So you are correct. Okay? You're good. All right. We're going to very quickly pop to page 57. And I'm going to just let you know what you do if you have a whole number. Okay, say they don't give you the specific actual number, like 12 wouldn't be 12, it would actually be, 11.9, blah, 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 blah. But what if they only give you 12? What happens with our sig figs? Page 57. Well, 12 has 2 sig figs, 13 has 2 sig figs. So if we multiply, and the 12 has a percent abundance of 98.90, the 13 has an abundance of 1.10. So when we multiply these, we get 11.868. And we get 0.143. But there's no flash. The flash has gone for a walk. I don't know where the flash is. I need to find a new thing. Yes? Yes, you may. 2 sig figs. Yes? 2 sig figs. Here is our uncertain digit. Here is our uncertain digit. So when we add it up, we get only 2 digits, so we can't do any better than 12. Okay? So that's really the only thing that's different here. This is just another example. Feel free to read through it if you want to. And what we're going to do for the rest of class today is we have 20 minutes left. You can get caught up on quizzes. You can do page 58 and 59. And the third thing you can do is you can do the overall review for the test, which is 4.6A and 4.6B. Okay? Is it an actual test? It's going to be like worth about half the marks of a regular test. No retakes. This one's one and done. Okay? Because it should be something that you guys are good at from last year. And if it was one of those people who didn't study enough, Mahan, he's not listening. He's not listening. But if you're one of those people who didn't study enough for Unit 2 and you're like, oh no, it went poorly, you still have like another 5 days to study for Unit 3. Okay? Yes. 4.
I was going to ask, did you finish working my metric quiz yesterday?
No.
Do you think I could, like the last question, like the extending one?
Uh-huh.
The diamond one, I didn't get enough time to do it.
Okay, yeah.
Do you think
Yeah, if I can find it.
All right,
Yeah.
If you can find it.
Hi. You would take 9B. Yeah. Hi. And you need to figure out what quizzes you're missing. If anyone needs to know what quizzes you're missing, I can let you know. All right, so. There we are. So you need 8, 3. This is a terrible pen for that, but that's okay. I'm going with it. And you need 9, 10, 11. Okay. There you
I
go.
love that one back there.
Yeah. Yes.
I have a question.
Yes.
So you know how here you're supposed to find like basically the electron and the protons?
Yeah.
I just want to know, for example, like in the red zone, how am I supposed to find electrons for iron, for example?
Okay, so a neutral atom of iron will have 26 electrons. And then,
So I would write, but this is like proton.
so this is 26, but we have a 2 positive charge, which means we have 2 more positives than negatives.
Oh, so this would be 28. And this would
No,
be
you cannot change the number of protons.
I'm confused.
Okay, how do you get 2 more positives than negatives if this number has to stay as 26?
So then we can put the negatives, so we make the electrons less.
Yes.
Ah.
Uh-huh.
Oh.
Uh-huh.
It's easy to
Uh-huh.
Went in there for like 20 minutes, and like, oh, we're gonna kill it.
Hello, Jade.
I want to know if you have my quiz 10.
Yes, I have a whole bunch of stuff to give back. Do you know people's names? No. Okay.
Yeah.
Okay. You know what? You can just stand there and like hand them out though and yell people's names like I do.
Oh.
Yeah? Do you want to do that? Are you comfortable doing that?
No.
No. Is anybody comfortable standing up here and handing out quizzes? You'll do it? Okay, excellent. So you just say Kasumi?
Quiz 8?
That is quiz 8. Yes.
Who's Kasumi?
Because I give the same quizzes to my Science 9 class. Kasumi! No, Kasumi. Oh, this is my wrong block. That's why. I'm so sorry. That's block 8. No wonder. There you go. Let's try this one. Hi.
I have a question. I want to know, did I use any quizzes or
Did you miss any quizzes? Is that what you want to know? Okay, let's see. Nope.
no?
No, you have not missed any quizzes. You got 5 out of 6 on quiz 11.
Jason? Can I quiz again if I want?
Jason? Yo, where's Jason?
You need to listen to Abbas in here. He's handing out your quizzes because I'm answering other questions.
Is there different?
Hi.
What's the
So for this one, 85, 87. Yep. And you have to go with very few sig figs. Yep.
So I kept on writing from it. And then
Zenny?
I had read them like.
Zenny!
Yeah, named the.
Got to project your voice.
And now it's saying.
That's okay. I'll do it. No worries. Nobody's here now. Okay, Ryan. Aya. Shiho. Ryan. Shiho's, yes. Delcine. Yunha. Jade. Yes.
Could you use the washroom real quick?
Yeah. Alex. Anna. Amir.
Thank you.
Dylan. Brooklyn. Kason. Thank you. There we go. Zenny. Aya. Shiho.
Thank you.
Yunha. Do you want to pick up Yunha's as
Yes,
well?
thank you.
Yes. Jacob. Yes. And I have more from the other day. Amir. Phosphorus is, what's the name of the ion?
The quizzes we just did is not based on what the test is going to be.
Yeah. So basically the test is going to be like 4.6A and 4.6B where they're all like mixed together.
Like
Yeah.
all that acid.
Like everything's in there. So there's going to be hydrates, acids, Roman numerals, no Roman numerals, covalent. Yeah.
Okay,
Everything.
hydrates too.
Yeah. Yeah.
So-
Yes.
Yeah.
Anna. Jacob. Ayush is in the washroom. Oh, and I've got progress reports. Mahan, I have your progress report. Jacob. Jade. Zenny. Andy's not here. Jade, sorry. One more. Ayush. Sabina. Jacob. Sorry. We're just getting you your daily exercise. Brooklyn. Abby.
This was my reaching for a quiz with my to do it together.
Yeah, for sure. Yeah.
Bro.
Sure. Yeah. See. Hi,
I have a
Brendan.
question.
Yes.
So when I'm doing the formulas, when do I notice that the H is crunched or in the back?
It goes on the end when it is H on the end on COO.
That's it?
Yeah.
That's the only time?
It becomes COOH, and that's it. That's the only time.
Okay.
Yeah.
Oh, thank you.
Yeah. Alex. Yeah.
Like all the shapes I know, but like I keep forgetting about it. Like metal, no frequencies, only the like some. I remember other shapes, but Moses, I keep on forgetting it.
You want to take a look at that? Yeah. Perfect. Oh. Like. Yeah. Like this. Let's see. Yeah. Yeah, I haven't got those yet. Yeah, I've been sending out reports to parents. So yeah, no, I haven't worked them yet, but I will get to them. I can do that now. Yeah, no, we're good.
Thank you.
Yeah.
Wait, no, that happens 100, 1,000 years. Centimeters, like 2 meters.
Okay, too. And that is mine. And Sabina.
Wait, we didn't do the comments. Oh, yeah. Yeah. You're like, what is that? It's a structural form.
Oh, yeah.
So like. Sorry.
Yeah, see, that's where when I looked at it, that's where I went, oh, you did it wrong. Yeah. Oh my God. Oh, we don't have that. No, if you look in the doors, we don't have that. What? Are we have to look into that? No. Oh my God. The one is so cute. Is it this? And this? Oh my God. Okay. But it was fine, because you're with everything else. But like, yeah. Oh, I mean, it's terrible. No, it's okay. You can do everything else. It's fine.
Well, they know.
Maybe. Maybe we're serious.
Later on, we get. I'll open you.
Yeah. Maybe. Do you know how to keep it?
I remember the one that called my business. Last time I saw it, but what's the
I'll just keep that for you.
I remember like last week.
Yeah. Does it matter?
Is that the time when I was like still fresh at this stuff?
Yeah.
You know?
Yeah.
Alright, so yeah, I'm playing.
Yeah. Oh, by the way, everyone, I have an announcement to make. You're not going to like it, but here we are. I got really grouchy yesterday because I hadn't had lunch. And then in block 4, everyone was like, can I redo? They got their progress report and they were like, can I redo this quiz from 5,000 years ago? And can I redo this quiz and this quiz and this quiz and this quiz? And I was like, no. So at this point, we are now saying if the test for that section is over, there will be no more redoing the quiz. Does that make sense? Because redoing quizzes is meant to prepare you for the test. Okay, so starting from this point onward, if you've already redone one, that's fine. But from this point onward, if it's after the test, no more quiz redos. Yes? Because it drives me crazy otherwise. Because I'm like trying to mark the test and I'm still getting people handing in quizzes. Jade.
Where is the?
Oh, sorry, Jade.
No, where's the 9 and 10?
Abby. Yay. Was that quiz 9 or 10? 9. Cool. Thank you. Kusei.
You're gonna roll up a joint, you know? Not big.
Ayush. Those are the quizzes you're missing.
With 1A and
9 to 11.
9 to 11.
Yeah.
I'm doing quiz number 8.
Good. Jay. Those are the quizzes you're missing.
Yeah, I will do. I'm doing 9 and I'll probably
Cool.
do 10. And then
Cool. Zenny.
It's like what, when you're. I'm missing ones, right?
Those are the quizzes you're missing.
thank you.
Yeah. Nima. Those are the quizzes you're missing. Abbasin. Those are the quizzes you're missing, 9 through 11. Okay?
Yeah.
I'm sorry to be a bother.
No problem.
The quiz that I did with Sabina, we did at the exact same time. and
Uh-huh.
I did it, and she got it back and I haven't.
Oh, which one was it?
I hopes. Yeah.
Oh, yeah, I just haven't marked those yet.
Okay.
Yeah, sorry.
Okay.
Okay. Yun. Yunha. Those are the quizzes you're missing. Okay. Julia. That's the quiz you're missing. Ethan. Thank you.
No.
Those are the quizzes you're missing. Okay. Hi.
3, 8, 9, 3, 8, 10.
Nice. Thank you.
But I'm still missing number 11. I didn't study for that. So.
You're which one? What?
Number
Okay.
11.
Okay. So you're going to study for those, write them on Monday. Okay. Cool. Thank you. Yeah.
I need to think.
Excellent.
Thank you.
Kusei. Abby, you know you're missing quiz 11, right? Yeah. Okay, come here then. I'll give that to you. That's the quiz you're missing. 11.
Oh,
Yeah.
I'm thinking right now.
Okay, perfect. Abby? John? Those are the quizzes you're missing.
Thank you.
Okay? Alex?
Thank you.
Just quiz 11.
11? Okay.
Yeah. Yeah. Okay. Brennan. You are missing quizzes 9 through 11. Yep, there you go. Brooklyn.
Oh, wait, it might be.
Those are the quizzes you're missing? Okay. Jacob, you just handed the last one in, right?
I'm doing 11.
You're doing the last one, perfect, perfect. And everyone else who is here, I've talked to already. Okay, cool. Have a great weekend, study hard. Okay? You want to knock this one out of the park, right? Absolutely. Yeah, sure. Not a problem.
I understand that I can't take it home. Can I leave it until Monday?
Do you want to just take it home and bring it to me on Monday?
Okay.
Yes.
I won't fill it.
Don't cheat, just write it in. Yeah, it's all good. Thank you, Kusei. If you've not done 11, then you're doing 11.
I miss man. Thank you.
Bye. Have a good weekend. Thank you for the calculator back.
I did love yesterday.
Then you're good. I'm going to just let people know what quizzes they're missing today and a few things like that. Hi. Okay, no problem. No, our lesson should finish early and it's also been recorded, so yeah, cool.